Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today with lesson number 13 in our new Arduino tutorial series where we are building a non-axis inertial measurement system. What we are going to do today is we are going to learn how to install Visual-Python or Vpython, which is an add-on program to Python, which allows us to do some really cool 3D simulations. And so what I will need you to do is pour yourself a nice big mug of iced coffee. I will need you to get your gear out, and then we will give you a quick recap of what we are trying to do in this lesson. We are working with the BNO 055 Adafruit inertial measurement sensor connected to an Arduino Nano. Now, in the first 12 lessons, what we did was we programmed the Nano in the BNO 055 where we could go out and get data from it, and then we could come up with nice approximations for roll, pitch, and yaw. Okay, and then in lesson number 12, we took that roll, pitch, and yaw data that we are constantly collecting, and we threw it to Python on the desktop, and in Python, we caught it. Okay, so now we have these data channels coming from the sensor into Python. Now we want to do something useful with it. So I'm going to kind of tweak your interest and show you where we are going. We're not going to get all the way there today, but we are going to get a good ways towards it. And so what you see is I've got my system here in the real world. If you're just jumping into this lesson and you want to play along at home, look down in the description. I have links to the hardware that you need so that you can play along with at home with the same hardware. But I've got this object in the real world, and then using Vpython, I've created a representation of it in the virtual world. You can see I got the breadboard, I've got the BNO 055, and I've got the Arduino Nano. Now here's where the magic happens. I get the board in the real world, and then look at this. As I rotate it in the real world, my Vpython simulation rotates in the virtual world. Oh, what? What? You're interested in roll? Let's roll it. Okay, let's roll it. Somebody else said pitch? Let's pitch. Did I hear somebody say roll and pitch at the same time? Okay, well, I will roll it up, and then while it's up, I will rotate it, and then we will go into a nosedive, and then we will come back down, and then we will come over and roll all the way around. So you can see anything that I do in the real world is being matched in the virtual world. So I think that that is just a super, super neat thing to do. And so what I'm going to show you to do today is I'm going to show you how to install Vpython, and we're going to write our first few Vpython. We're going to write our first few Vpython programs. So we're not going to get to the point today of doing this, but we are going to get to the point of kind of becoming familiar with Vpython. So let's see where we need to go now. I think what I need you to do is open up a command prompt in Windows. So you go down to your little search box and you type CMD. It comes up command prompt. You want to open your command prompt. All right, now that you have your command prompt, what I need you to do, I will give you a second to get there. Okay. Okay, so once you get your command prompt, and I've got a little bit of a window problem there. All right, so you've got your command prompt. Now, in lesson number 11, I showed you how to install Python. So you should already have Python on your system. If you're an expert, just go install Vpython. You already know what you're doing. But if you don't really know what you're doing with Python, you need to make sure that you install it the way that I showed in lesson number 11. Because if you just have some old and random version of Python, what I'm going to show you here might not work. There is a helper program for Python called pip, and pip helps you install libraries. And if you install Python the way that I showed you in lesson number 11, you already have pip. If you didn't do that, then this might not work because you might not have pip. But if you've been following along, and if you did what we did in lesson number 11, this should work for you. We are going to say pip install. What do we want to install? Vpython. Okay, and it comes down collecting cache, all this stuff. It looks really happy, right? And then we come down, and what you can see is it says that it was successfully installed. And so that is really good news. So what I am going to do now is I am going to call up our Python environment. Remember our development environment, it was IDLE. So we search on idle and we see that it finds it. And so I open up a new fresh Python window. And you can see that our Python is opening up in a shell. And the shell is just basically the environment that allows you to write a program one command at a time. So you can kind of play with the Python interpreter by just typing individual commands. We want to write a real program, but I cannot resist checking to see if our install was successful. So at these little command prompts, what you can type is import Vpython. And if the library was successfully installed, it should just do it without complaining. So that means that the library was installed. So let's see if we can start writing a program here. So I'm going to come up under File, and I'm going to go to New File. And this brings me up to a window that I can actually write a program in. I'm trying to be mindful to make sure that you get a view that you can see what you need to see. Okay, so let's write our first Vpython program. Okay, I think that's good. Okay, so what do we want to do? Well, if we're going to use Vpython, we're going to need to import it. So I'm going to say from Vpython import star, which means go out, get everything in Vpython and bring it in. Okay, now what I would like to do, I believe, is I would like to give my first Vpython command. And so let's just say x is equal to a box, and then open, close. And so this is about as simple as it could be. This should draw a box. So we're going to come up and say run module. And then what this does is it wants me to save it. And so I will save it as first Vpython. Yes, replace. Okay. So now it is running. It goes up to the browser and it opens up the visualization in the browser. So let me make sure that you can see this properly. Once I get these windows sized right, it should go fast. But the first time we run it, we got to get the windows the right size for you to see. I think that looks pretty good. So it made a box. Now with your mouse, the right mouse button, right mouse click and hold it. And then you can rotate this around and you see that you have a nice cube. That was pretty fun. Let's go and let's do another one. I have so many windows here, it is going to drive me insane. Let me kill that one. Okay, so now I need to call my programming window back up. Okay, there it is. Let me kill a few of these windows. Just don't hate on me, but it's just hard for me to keep up because I have too many windows open. Okay. Okay, I think this will work now. So we want to go back to our program window. Okay, so we made a box. Let's think, what else could we make? We could also make a sphere. Okay, so we're just going to make a box and make a sphere. We're not putting any particular thought in this. I'm just kind of showing you some stuff that you can build. Okay, there's the sphere. What happened to the box? Well, the sphere is probably so big that the box is inside of it. So let's see if I can fix that. Maybe if I put that there like that. Okay, let's make the sphere. Let's give it a radius of 1. Okay, and the box, let's give it a length, L-E-N-G, length. Length is hard to spell, isn't it? Length is equal to 6. Let's say width is equal to 2, and let's say height is equal to 0.2. All right, so now let's run this. Pops up. Okay, you can actually see it now. So you see I've got a sphere and I've got a box. Okay, what is something that you notice about that box? Do you notice something interesting about the box? You know, it starts looking like my breadboard, right? So if you're asking yourself, what are the dimensions of whatever you want to be in. If you're in miles, just think in miles, right? If you want to be in inches, think in inches. And just use the same unit, and then it'll all work, because this is just kind of showing you a visual representation. So it'll work kind of whatever units that you want to use. But if you're going to do something like really big, we can actually scale our view window to match what it is. But we'll get into that later. Right now, we are just kind of getting our hands around some of the basics. And so what else could we do? Well, what if we came in and we said color equal color, color equal color dot red. Let me do this right. Color equal color dot red. Okay, so that should make it red. And then let's make the ball color equal color dot green. And so we are putting some colors on here. Okay, look at that, red and green. So that's pretty neat. Let's see what else we can do. What if I want to kind of make, there's just so many different parameters, so let's just kind of play around with these. What if I wanted to make opacity? Let's say that I want the sphere to kind of be like opacity. That's like how solid it is. Its opacity is the opposite of transparency. So let's say opacity is equal to 0.5. So that's kind of like half there, half not there. So you can kind of see through the sphere this time. So let's say run module. Okay, do you see how you're kind of looking through the sphere now? The sphere is kind of become a little bit transparent. Okay, that's kind of neat. Let's set it less. That's still kind of solid. Let's set it like at 0.2. We should really kind of be seeing through it at 0.2. Yeah, you see you can kind of just barely see it there. It's just kind of like a bubble now. Okay, let's go back and set the color of our breadboard back to white, because that is kind of what our breadboard is in the real world. So let's go back and say run module. So this should give us a white breadboard that sort of is like what the breadboard is in the real world. Okay, see, that's kind of nice. That sort of really matches that dimension of the breadboard pretty well. Okay, so I think that I'm going to get rid of that sphere, because I really don't want it. Just showed you one of the things that you could do. What you can also do is you could also say that like y is equal to a cylinder, and let's say the cylinder has a length of length equal to, let's make it 6. Now what the difference is, a box, it puts the center of the box at the origin, but for a cylinder it puts the face at the origin. And so this probably is going to be not perfectly overlapping, just because it puts cylinders and boxes in different places. So length is equal to 6, and let's say radius is equal to 0.5, because if, yeah, radius is equal to 0.5, and let's say color equal color dot yellow. Color is equal to color dot yellow. All right, let's try that. I'm trying to give you enough commands where you can really get going. Okay, this is kind of like what I predicted, right? That this is the origin here, and so it puts a box around the origin, but a cylinder, it starts at the origin and goes out. So it's kind of neat. That's like almost like a neat shape that we made there. But what if we wanted to line these things up? Well, we've talked about we can control their size, we can control their color, we can control their opacity, we can also control their position. Now, one thing I could do is I could come here at this and I could put position is equal to, now if I'm going to do position, I need an X, a Y, and a Z. And so let me go back up here, and you can see that it shot it out along the x-axis. So this is the positive x direction, this is the negative x, and what you'll find is x is like this, y is like this, and then z is coming out of the screen towards you. So where would I want this to be? I don't want it at 0, 0, 0, x, y, z. I want it at -3, and then I don't want to move it in the other direction, so it would be -3, 0, 0. And if I do that, it should overlap that box. Okay, so I could say position is equal to, and when you give it 3 numbers, you have to give it as a vector. So you're going to say vector, and there's a lot of things in three-dimensional space that comes as 3 numbers, and so those are sent as a vector. So I say position is equal to vector, and then you give it the 3 numbers. X, I wanted -3, comma 0, comma 0. All right, and then put commas between your parameters. Does that look good? Let's try running that. Run module. Okay. Okay, look at that. Lined up perfectly. Okay, just exactly what we were expecting and just exactly what we wanted. Now this is going to be something very important that I'm going to show you here. After you have created an object, I created the object box or X, and I created the object Y. Let's say that I didn't give it a position. If I didn't give it the position, right, it's going to be back like it was before. But what I want you to see is you can, okay, you can change it later. And how would you do that? I would say what object I'm working with, Y, and then dot, Y dot, what do you want to change? I want to change the position. And now Y dot position is going to be equal to, it's 3 numbers, so what do I have to do? I have to give it to it as a vector. And then what do I want? -3, comma 0, comma 0. All right. That should work. So let's run it. Boom. So you see, I created it in the wrong position, but then the first step was to move it. So you can modify these things after you've made them. Okay, so let's look and say, like, what I could do is I could say the box X dot, what if I change the opacity here later? Okay, X dot opacity is equal to, it's not a vector, so I can just give it a number, 0.2. I'll make it where it's kind of transparent after the fact. Okay, so you see the box now, you can barely see it, so that's kind of neat. This is already, man, we just only been at this half an hour, and this is already getting kind of fun. Now this is why it is important. Let's say that I had while, okay, while true. Okay, when is true true? True is always true. Does that need to be a, okay, capital T, while true. So this will loop forever. While true. Why? Because true is always true. And then remember that our while loops are done with indentation, so as long as I'm indented. Let's say that up here we just create j equals 0 and change equal 1. Okay, so now let's come up and let's say j is equal to j plus 1. Okay, and then what I want to do is I want to say x, that's the box, dot length is equal to, or let's do the cylinder. Let's say y dot length is equal to j. And instead of j is equal to j plus 1, j is equal to j plus change. Okay, y dot length is equal to j, and so what's it going to do? It's going to make it 1, and then 2, and then 3, and then 4, and then 5, and so it's going to make it longer and longer. See, I'm going to dynamically change that thing. So y is dot length is equal to j, and then let's just say if j equal 10, then what do I want to do? Well, I want to make change equal -1. So this is just saying I don't want it to continue to grow forever, so once it gets to 10, then I want to turn it around, and then I am going to say also if j equal 1, I'm trying to make sure this might do something crazy. That's why I hate programming with just on the fly. So if j equal 1, change is going to be equal to 1. And so the first time through this might do something strange, so I'm just going to cheat and start at 2. Okay, so now what I probably need to do is I probably need to import time, and then here I need to do a sleep of, let's say, 0.1, just so it doesn't go too fast. And then one of the things with Vpython, if you're going to be dynamically changing something, you need to put a rate in it. So I just need to say rate of 20. I'll explain more about this later, but if you're dynamically changing the scene, you need to put a rate in. And probably if I'm doing that rate, I don't need the sleep. Okay, this is going to be crazy, but let's see what happens. Run module. Okay, look at that. Look at that. Boom! Do you see that? Boom! We have got an animated scene here. Now, I want to come back over here. That is like way, way, way too much, and so the change, let's see. Let's make change instead of, let's make it 0.1. Okay. And then let's make this 0.1, and this should be a little bit smoother. So let's try this. Oh yeah, look at that. Okay, that is this craziness where okay, you see what's happening is that when it comes back down, then it just switches back around. So I have to think through this a little bit better. So let me let's say 0.01. It'll work one time. Like that. Okay. Run module. So this should go really, really in small little steps. Okay, you see that? Look at that. Very nicely. You could almost see, like here, we're almost building a thermometer. Okay, I can't help it. Let's see if we can make this look like a thermometer. Okay, so we're going to come back over here, and the cylinder should be red, right? D. And then what we are also going to need is we're going to need a z is equal to a sphere. And the sphere is going to need to have a radius of, let's say radius equal 1. I think that would be kind of good. Color equal color dot red. Okay, now we need to think about where we are going to put this. And so let's come down. I could put it inside the parameters, like I could put the position here, or I could just come down here and change it z dot position. And probably where we should go is -3 would put the center. Yeah, I think -3 would probably be good. We can look and see how it would look like that. Okay, so now let's run this thing and see what happens. Is it changing? I seem to have killed the program where it doesn't want to change. Oh no, is it growing? What did I do to this crazy thing that made it stop working? Change is equal to 2. Let's make change. Let's go back. Let's make this 0.1, 0.1. I'm trying to think of why just adding that sphere seemed to have kind of killed the y dot length. I still have the cylinder. Let's try it again. I think I saw an error there. Let's go back. So it created the box, but then it died for an error. And so let's see what the error is. All right. So that makes sense. Did you guys catch that? I'm using the old Python. And what did I forget after lecturing you guys? You have to put an equal what? Vector. You have to put an equal vector, and I just kind of put it as a parameter. So I hope you guys caught that. Okay, so this should be alive this time. Ah, yes, look at that. Oh, yeah, that is great. It works one time, and then, like we said, I would have to think through doing this a little more carefully. The point here is, the point that I'm making is that you can animate things, right? You can animate things. So let's see. Okay, so you can animate them, and that's how we are making this simulation work. I am sending roll, pitch, and yaw from the sensor, and then I am dynamically changing the way the devices are pointing based on the data. So that's kind of good. What we want to see is understand that I've shown you you can change position of things, and you can change size of things, and you can change color of things. But there's also, like here is moving, right? But besides moving, you can rotate things. So we need to think a little bit about that. And the way you do that, the way you get the orientation is it's called the axes command, okay? And so like if you think of this, imagine that this box has an axis that is pointing along the x direction. And so now that that is pointing in the x direction, I can change the axis with an axis statement, and I can change in 3 dimensions where it is pointing. And so let's make some arrows up here. Okay, so I'm just going to make an X arrow, and this is going to be, let's say, length is equal to 2, and let's say color equal color dot red. Okay, and then this should just be too long. Let me give it a shaft width as well, just so I don't get something crazy. Shaft width is equal to 0.1, and then put my comma in. Okay, so now in that, close that parentheses. So this should put just a red arrow pointing down the x-axis. Length. Did you see guys see that? Length. Okay. TH. Length. Okay, run module. What is wrong with this? Invalid syntax. I forgot to say X arrow is equal to arrow. Hope you guys were yelling at me there. All right. And don't act like you're not making just as many mistakes as I am. Okay. And what is happening here? I know what is happening. You can't see it because of this other stuff, right? It's hiding behind the other things that we've already done. So let's come in here and let's take out this nonsense, and let's just think about our arrows. So now I should have an arrow, and let's make it 6 just to make sure that we can see it. And then I'm also going to make my cylinder, and I'll do it down here. So I'll just say y dot opacity is equal to 0.2, and that will make sure that we can see the arrow. All right, so let's run it. We should have an arrow somewhere. Where is my arrow? Maybe my arrow is inside of the sphere. So let's come back here, and what I should do is say z dot opacity is equal to 0.2. Run module. So this should make that kind of still no arrow. Still no arrow. What is wrong with my arrow command? We'll go back over here. Let me get rid of this Z stuff, the sphere. And I have X arrow is arrow length is equal to 6. Shaft width is 0.1. Color is equal to color dot red. And we'll figure out why we're not seeing this. Is probably something stupid. But with those opacities turned down, I should be able to see these. Oh, maybe it's hiding inside of the breadboard. And I got to take this Z command out, which is what killed it. So I think that it died before it got to the arrow command. But also I better make this like a 0.4 just to make sure that it doesn't hide inside of the box. Do you guys see I was changing a parameter that didn't exist, and so it was killing the program? Okay. Now that is a very, very ugly arrow. In fact, that is one of the ugliest arrows that I have ever seen. So what kind of crazy parameter did I put on that that led to that crazy looking arrow? X arrow is equal to length is 6, shaft width is 4, color is equal to color dot red. And I should be able to get that crazy thing to work. Okay, I'm just going to take the cylinder out now. You see, sometimes when things aren't working right, just simplify. So I'm going to get back to some very simple things. And also, let me change the x dot opacity is equal to 0.2. And then since I don't have a y object, I need to take y opacity out. So now let's run. You would think that I would be able at this point in my life make a simple arrow. For some reason the arrow, you know what I think I need to do with the arrow? I think it's confused because I didn't tell the arrow what direction to point. So if you're going to point an arrow, you better tell it where you want it to go. And so I could put an axis statement here. I could say axis equal vector. I could put it up there when I created it, but I'm going to put it here. X arrow. What parameter do I want to change? Dot axis. What direction do I want it to point? I want it to point along the x-axis. So what is the x-axis? On x comma y comma z, it's the first one. So x arrow dot axis is equal to a vector. And where am I going to point? The 1, 0, 0 direction. So I'm going to go 1 in the x direction, 0 in the y direction, and 0 in the z direction. So this should make it work. Darn it! Darn it! What is wrong with that? Maybe I better give it a axis when I create it. I've never quite run into this before. Control V. Now, why do I not do things perfectly? I'm not deliberately making these mistakes, but you can kind of see how to debug things. I am not understanding Do I have some crazy error that I don't see in here? X arrow is, let me take that off. X arrow is equal to axis vector 1, 0, 0. Length is 6. Shaft width is 0.4. Color equal color dot red. That really looks good to me. I'm going to go crazy here. Okay. I have no idea. I guess it wanted that axis right off the bat. It wanted that axis right off the bat. Okay, so now putting that axis right off the bat. All right. So now what we want to do is we want to say Y arrow. And let me just copy this one, and then we'll just change what we want. So I'll do a Control C. And I will get back over here. Guys, it's kind of awkward because I have to make my font big so you can see it, but then I start running off the screen, so I'll say Control V. Okay, now what is this? I want this to be Y arrow, and then where would Y point? Well, that would be X, Y, Z. It would be 0, 1, 0, and that should point along the Y axis. So this will be 0, and this will be 1, and then this will be 0. And I thought that was a little awkward, so I'm going to put it like at 0.1 and 0.1. And then I think I'm going to make our links 2. I just made them big so that we could see them. Color is equal to red, green, blue. So that way, always think red, green, blue, X, Y, Z. So I always make Y green, and Z arrow is equal to arrow, and then axis equal vector. And where would this one go for Z? X, Y, Z, it would go 0, 0, 1. Am I typing this in instead of, I think I am, length instead of copying and pasting. We've got this much invested though, we might as well do it. So this will be shaft width equal 0.1, and then color equal color dot blue, and then don't forget to close up your parentheses. All right, let's run this thing. We should have our coordinate axes. Okay, look at that. You see how this is kind of neat here? Although I need to change my links, right? I got goofiness going on with the links. So let's see. Why do I have goofiness going on with the length? I set the length of all of those to 2. Okay, guys. Oh my goodness. Were you guys like screaming at me? Were you screaming at me? Length. It was in spelling error. And that's one of the kind of peculiar things about Vpython. It would have been nice if it would have given me an error. It didn't give me it didn't give me an error. It just did a stupid thing. So now let's run module. And so you see I misspelled that. That's why it was not working. We come up here, and then boom, look at that. We have X, we have Y, and we have Z. And let's see if I can get this where you can see it. All right, now remember red, green, blue. Also remember the right-hand rule. You go from X to Y, and then Z is where your thumb is. X is red, so think of pointing your fingers curling from red to green, X to Y, and then Z is the positive direction. And as I'm building models, I like to put a coordinate axis so I can remember red, green, blue is X, Y, Z. Okay, so now let's go back in there now that we're past our little problem here. And let's go back and put our X in, and our X is, or let's just say breadboard. My breadboard is a box. And I'll just give it dimensions kind of like the real world. It is a box that has a length is equal to 6. It has a width equal to 2. And it has a height which is equal to 0.2. And then I'm going to put an opacity equal to about 0.5 just so I can kind of see through it if I need to. And then I'm not going to put a color, all right, and then I will just leave it there, and then let's look at it. Okay, run module. Okay, so I've got a coordinate axis and I've got my breadboard. All right, and already you should kind of be thinking of that as this breadboard like this. Okay, so now what could I do? Hey, you know what I could do? I could put like my Arduino on there, right? My Arduino. So let's think about putting our Arduino on there. So I'm going to come back to our code view. Okay, I'm going to come back to our code view. Let me get this line back up with you. Okay, now I'm going to create another box. And what am I going to call this? I'm going to call it the nano. And the nano is a what? It is a box. Okay, and I can make it kind of the size. I can make it the length is equal to about 1.75, and then the width is equal to about 0.6, and then what do I want? The height is equal to about 0.1. Okay, and then I am going to 0.6, 0.1. Okay, now I've got to put it somewhere. All right, now you've got to kind of be thinking about the breadboard. How thick did we make the breadboard? So we made the breadboard 0.1. Okay, or we made the breadboard height up here 0.2, and so that is in the y direction, and so we need to think about where we want it. First of all, if the breadboard was 6 and this is 0, and I think we're building it kind of in this direction, so if we're like, this is the 0 position, we want that breadboard to be about -2, or we want the nano to be about -2 in x. Okay, so that means that we don't want it in the center on x. We want it like to scoot it 2 back, and that way it's not sitting here right in the center, it's like 2 inches back. I hope that makes sense. Okay, now we want to think about the y. Now the y is the up direction, and so if we don't bring it up, it's going to be inside the board. Well, how thick was the board? The board was 0.2, but if you think about the origin, that's 0.1 above the origin and 0.1 below it. So then I want the nano to be up by 0.1. But since we're oriented towards the center, if I just put it up by 0.1, then half of it is going to be down in the board. So I want to add half of the breadboard plus half of the nano. And so I believe that would be -2. Okay, and where did I go over here? I need to make sure that I'm not doing something stupid here. Okay, so we're going to go the nano is going to be at -2, and then it is going to be up by half of the board thickness, which would be 0.1, plus half of the nano height, which would be 0.05. And that should put it the bottom of the nano right on the top of the board. Okay, and then in z is this direction, we want it lined up, so that would be 0. Okay, that is kind of crazy, right? And position is equal to vector, so I won't make that mistake again, right? Okay, and then we need to close the overall command with that. All right, let's try running this. All right, boom. Look at that, huh? Look at that. Tell me what, I want you to look here and look how perfectly we got the bottom of the nano sitting on the top of the board. Somebody tell me what I should do. Look at the nano. We want it to look like the nano. Somebody tell me what we should do. We should be in here, and on this nano, what should we do? Color equal color dot green. Does that make sense? Color is equal to color dot green. Boom. Do you see that? See, I like keeping this X, Y, and Z axis so it helps me as we're adding more components. Okay, what do I want to add now? I want to add the B&O 055. And so I come over here, and I think I am just going to call that a B&O, that's good enough, is equal to a box. And let's not forget color this time. Color equal color dot blue. And then what do we want on that? It's about a length is equal to, it's about 0.75, and or no, the length is about 1, the width is equal to about 0.75, and then the height, H-E-I-G-H-T, you want to say H-E-I-G-T-H, height, but it's height. Okay, so I've got the length, I've got the width, I've got the height, and now the position is what we've got to be careful of. So the position again is going to be, this time I think probably the position I would put at about minus 0.5, because I don't want to run it all the way back into the nano. Minus 0.5 would be good. And now we want half the thickness of the breadboard, because half above the origin, half below the origin. So we're half above, so that would be 0.1, plus we can add half of the thickness of the B&O, which is 0.05, and then again 0 and Z. You know, if we were really smart, what we would do is we would set like the height equal to 0.5, or we would say just a variable h is equal to 0.2, and then here we would put in equations, and that way if we change a parameter, we don't have to go in and completely redo our model. But I'm not going to worry about that right now. So we got our position, and now we close the overall command, and now let's see what happens. Run module. What did that not like? Oh my goodness. Okay. I did this again. No, box. Help me. Are you guys screaming at me what I did wrong? Color dot blue, length 0.1, width is 0.75, comma. Height. Oh, I didn't put a height in. Okay. Height is equal to 0.1. All right, let's run that. H-E-I-G-H-T is equal to 0.1. Position, I didn't do the vector thing. All right, position equal vector. The old Python did these things differently, and I'm still like on the old Python, and I got to get in better habits here. I think it'll run this time. Okay, and look at that. I put some crazy thing in there for dimensions. So let's go back and look on the B&O and see what I put on the dimensions that were crazy. Okay. Length should be 1, not 0.1. Were you guys yelling at me about that? I hope so. Okay, and guys, I don't go in and practice these things to try to be perfect in front of you, because when you code, you're going to make mistakes. And so I just kind of go on the fly, and I make mistakes like you make mistakes. And then when I make those mistakes, I try to talk out loud as we go through to try to figure it out. But do you see how I've kind of got an animation that is starting to look like the real world? And so what your homework assignment is going to be on this thing is to go in, and then I want you guys to either send me pictures of your of your simulation here, and let's see who can be the most obsessive compulsive about getting the most accuracy in their model. Okay, like, look at all the crazy things that you could do. Maybe you would need to go in and do a little bit more study. Maybe you would want to like put these color lines on, these color lines that you see on the board. You could do that, just a very long box that's in the right position, that is very, small length, small width, long thing, and you could put, you could make that just a small box. You could probably put a couple of boxes here for these things. If you put this as a box, you're then going to have to do an axis statement so that you rotate it after you get in position. But you guys just get familiar with Vpython. I've kind of given you an overview of the commands, and I think I've given you enough where you can go in and you can make this visualization a lot more accurate. What I'm going to do in the next lesson is I'm going to go in, and kind of where I messed up today was I was trying to do it on the fly and making the thing come back and forth. I did it with while loops where I should have just gone in and written a for loop. 2 for loops is the way I should have done it. But because I didn't do a real good job on that, next week I'm going to come in and show you how to kind of animate things and make them change in real time. So that's what we'll do next week. But what your homework is for this week is to come up with the most accurate representation of the board as you can, and just see how much detail you can put in there to get your virtual device looking more and more like your device in the real world. Okay, this has been kind of a long lesson, but I feel like you guys have learned some good stuff, and I feel like that we're well on our way to where our goal is. What is that? Hold on just a second. What our goal is. I'm going to get this back. Give me just a second. Okay. I just want to remind you of what our goal is. And we can come back over here. Here it is. Okay. What our goal is to have your animation come to life. Okay. Where that breadboard comes to life and exactly tracks what the real breadboard is doing. So the better that you make your breadboard, the better that you make your breadboard simulation, the more impressive this demonstration is going to be. So you guys go out and really work on the breadboard, and then that will go into future lessons. Okay, this has been kind of a tough lesson, and again, I was sort of doing things on the fly and a couple of errors in there, but when I make errors, it just allows you to sort of help develop those skills for debugging. Okay, really appreciate your comments down below. Subscribe to the channel, give us a thumbs up, and share this with other people. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.